It starts as a rock-hard, green fruit that tastes like raw potato. It ends as a sugary, golden banana chip consumed by the ton. Banana chips are not just a health food store item anymore. They're a billion-dollar global snack, with the Philippines and India leading the massive export charge. But the transformation is difficult. Unlike potatoes, bananas are sticky, irregularly shaped, and full of natural sugar that burns easily. How do factories turn millions of these fruits into uniform banana chips without creating a burnt, sticky mess? It requires a precise industrial ballet. The biggest enemy is the sap. This sticky latex bleeds from the cut fruit, gumming up slicers and staining machinery if not handled correctly. If the temperature is off by a few degrees, the sugar burns instantly. Today, we enter the mega factory to see the transformation from green skin to golden crisp. This facility operates 24 hours a day, processing hundreds of tons of raw fruit to keep up with global demand. Welcome inside the industrial fryer and flavoring plant of the global snack market. It begins here in the tropics, but we aren't using the grocery store Cavendish banana. That variety is too soft and sweet for making chips. We use the Saba or plain variety. These are cooking bananas, starchy, firm, and lower in sugar content than their dessert cousins. The green rule is strict. They must be harvested mature but unripe. If they show even a spot of yellow, the sugar content is too high for frying. Green means high starch. In the fryer, starch provides structure. If they are ripe, the sugar burns instantly, and the banana chip gets soggy instead of crispy. Truckloads arrive daily. Once harvested, the clock starts ticking. They must be processed within 48 hours before they start ripening naturally in the tropical heat.
Ponle el cartón aquí.
Logistics are tight. The bananas travel from the farm to the factory floor in less than a day to ensure maximum starch content.
Okay, grab the big ones first. Got it.
At the intake, workers separate the individual fingers from the main stalk. The green bananas are now ready for the first stage of their transformation. Any fruit showing signs of ripening is culled immediately. Only the hardest, greenest bananas make it past this point. To fight the sticky sap, the bananas are plunged into a hot water tank. This isn't to cook them, but to soften the skin and neutralize the latex. Some factories use steam tunnels. The heat penetrates just deep enough to loosen the bond between the skin and the flesh, making peeling significantly faster. Emerging from the steam, the bananas are now prepped. The skin is pliable, and the sticky sap has been largely contained. Despite automation, peeling is often done by hand because Saba bananas curve irregularly. A skilled worker can peel over 30 bananas a minute. The steam treatment makes the skins slide off easily, preventing the workers from struggling with the glue-like sap. Larger facilities use automated peelers that slit and squeeze the fruit. While faster, they require the bananas to be sized perfectly to avoid crushing. Mountains of green peels are generated every hour. In an efficient factory, nothing is wasted. These peels are sent to biomass boilers to power the factory or used as cattle feed. The peeled bananas are inspected once more. Any remaining skin must be trimmed off, as it will turn black and bitter in the fryer. Clean and peeled, the starchy fruits ascend to the slicer. They must be cut immediately to prevent oxidation. Like apples, bananas turn brown seconds after being exposed to air. A water buffer keeps them submerged and pristine until the blades are ready. From the tank, they are lifted directly into the high-speed rotary slicers. Safety is paramount. The slicing blades spin at thousands of RPM, fully enclosed behind heavy stainless steel guards. Inside, rotary blades spinning at high RPM slice the bananas. The thickness is calibrated to exactly 0.8 millimeters. Too thick and the center stays soggy. Too thin and it burns. Depending on the product, the blades can be changed to produce round coins, long diagonal chips, or even quarters. The slices fall immediately into a special treatment bath. Speed is critical here to stop the oxidation process instantly. They land in a solution of water, salt, and turmeric. Turmeric isn't just for flavor. It's a natural antioxidant that keeps the chips bright yellow and acts as a preservative. Without this bath, the fried chips would look grayish-brown. The turmeric ensures that signature golden, appetizing color. Salt is also infused at this stage. By soaking the raw slices in brine, the flavor penetrates deep into the chip before frying begins. Paddles guide the slices through the tank, ensuring they don't stick together. Plumped slices will result in soft, uncooked spots. After a few minutes of soaking, the slices emerge, transformed from chalky white to a vibrant, uniform yellow. Before frying, excess water must be removed. Air knives blast the surface of the chips. Too much water would lower the oil temperature and degrade the oil quality. A vibrating shaker bed spreads the slices into a single layer. They are now ready for the most dramatic step, the hot oil. We enter the fryer room. This massive continuous fryer is a river of hot oil, kept at a precise 170 degrees Celsius. The industry standard here is coconut oil. It has a high smoke point, is shelf stable, and imparts that signature tropical aroma that consumers expect. As the chips hit the oil, the water inside their cells boils instantly. This rapid evaporation creates the porous structure that gives the chip its crunch. Bananas float, so a submersion belt holds them down. They travel through this oil river for exactly the right amount of time to cook the starch completely. Sensors monitor the moisture evaporation. The goal is to bring the moisture content down from 70% to less than 4% in minutes. For savory chips, this is the end of cooking. But for the popular sweetened chips, this is only stage one. They emerge cooked, but not yet glazed. The chips pass through a curtain of sugar, syrup, or honey. This coating needs to be locked in, or the chips will be a sticky mess in the bag. They are dropped into a second fryer for a flash fry. This rapidly caramelizes the sugar glaze, turning it into a hard, glass-like candy shell. This two-stage process is the secret to the glistening look. It locks the sugar onto the surface, giving the chip that signature shine and extra crunch. Some premium brands use vacuum frying. By lowering the air pressure, water boils at just 90 degrees, preserving the natural color and nutrients better, though the process is slower. The chips emerge from the oil for the final time. They are golden, shiny, and over 100 degrees Celsius. Immediately, they hit a vibrating shaker. This bounces the chips to shake off excess oil, ensuring the final snack isn't greasy. For savory varieties like chili or barbecue, the chips enter a seasoning tumbler. As they roll, fine powder is sprayed onto the warm surface, sticking perfectly to the residual oil. You cannot pack hot chips. If you do, they will sweat inside the bag and lose their crunch. They must enter a long, cooling tunnel. As they cool, the sugar glaze undergoes a glass transition, hardening into that brittle, candy-like crunch we love. Before packaging, laser-guided optical sorters scan every single chip. A blast of air kicks out any chip that is too brown or burnt. Burnt chips taste bitter. This technology ensures that only the perfect, golden yellow slices make it to the bag. A final human inspection catches any fused clumps the machines missed. The finished chips accumulate on a wide belt, a golden river ready for bagging. Bucket elevators lift the delicate chips to the top of the packaging hall, being careful not to break them. Computer-controlled weighers calculate the perfect combination of chips to hit the target weight, say, exactly 100 grams, in a fraction of a second. We enter the packaging hall. Rows of machines turn rolls of foil into bags, fill them, and seal them faster than the eye can follow. The film is pulled over a forming collar to create a tube. Heat bars seal the back and bottom, creating the pouch. The measured dose of chips drops into the waiting bag. Crucially, a blast of nitrogen gas is injected just before sealing. This pushes out the oxygen, which would make the coconut oil go rancid. The jaws clamp down, heat sealing the top and cutting the bag loose. The nitrogen cushion protects the chips from crushing during shipping. Every bag passes through a metal detector to ensure no machinery parts have fallen in. Robotic arms or workers pack the bags and cartons. These chips are now ready to travel halfway around the world. Pallets are wrapped intact. In just a few hours, a green fruit has become a shelf-stable, globally exported snack. From the sticky sap of the jungle to the crunch in your pantry, the process is a masterpiece of food engineering. Whether you prefer the sweet, glass-like crunch of the glazed chips or the savory kick of the chili version, the Saba banana is the star.
Starting with our sweet glazed and salted varieties, we move to the fiery kick of chili and the smoky richness of BBQ.
Which do you prefer, sweet or savory? Let me know in the comments, and don't forget to subscribe for more industrial deep dives.